Number one, the graph of y equals fx for x interval of 0 to 10 is shown in the following diagram. The graph intercepts the axis at 10, 0 and 0, 5. Okay. This intercept point with y-axis and this one, the intercept point with x-axis. Write down the value of f4. If f4, the intercept point here, okay, equals 1. Okay, because if x equals 4, it means y equals 1 because that is the function of y equals fx. Okay, according to this information, y equals fx. So if x equals 4, y equals 1. So the answer here, 1. And part two is f composition f4. We need to find if f4 equals 1, this composition becomes f1. Okay, because f4 equals 1. So if f equals 1, if x equals 1, it means here y equals 3. So it is equal 3. And what if f inverse function and x equals 3? If x equals 3, it means if the function inverse of function x is y, fy. So if y equals 3, it means x equals 1. Next. On the axis above, sketch the graph of y equals inverse of x. Show clearly where the graph intercept the x-axis. So the graph intercept if this is 10, 0, the inverse of 10, 0 is here. Okay, 0, 10, and if this the inverse, if this the coordinate point is 0, 5, will be moved here. The intercept will be 5, 0. Okay, and if this is 1 and 3, so it becomes 3 and 1 here. What else? And if 4 and 1 would be 1 and 4 here. Okay. And after that, we can create the graph. Graph would be like this. Okay. Be like, okay. That's the graph. Two, solve tangent to x minus 5 equals 1 for x interval 0 to 180. So tangent to x minus 5, it equals 1 is tangent 45. Okay, so to x minus 5 equals 45. X equals 50. And x equals 50 over 2 equals 25. Right. So x equal 25. This is on the first quadrant. If we sketch the quadrant, this is the first quadrant. The interval x between 0 and 180. So the first quadrant and the second quadrant. I'm going to get the 25 degrees here. It's 25. And then after that, okay, this is 90 degrees. So it is 25 plus 90. So x equals 25. And then 25 plus 90, 115. Okay, so x equals 25 and 115. 25, it is, if in radian, this 5 over 36 pi. And if add half pi, 115, it's going to be 23 over 36 pi. Okay, so these are the solution. 3. Solve 3m squared plus 5m minus 2 equals 0. Okay, so you're going to factorize it and find the value of m. If we factorize, will be m or 3m here. Okay, 3m times m minus 2 and 5 will be minus 1 plus 2. So 3m minus 1 equals 0, or m plus 2 equals 0. So m equals 1 over 3, or m equals minus 2. This. Hence or otherwise, solve 3 multiply 9 power x plus 5 multiply 3 power x minus 2 equals 0. Let a equals 3 power x. So it means if 9 power x, it equals 3 power 2x. This is a squared. Okay, so I'm going to move here. Okay. So this equation being 3a squared plus 5a minus 3 equals 0. So similar with this equation, and the factorization becomes 3a minus 1 m plus 2 equals 0. So a equals 1 over 3. Sorry, this is a, not m. And a equals minus 2. If a equals 3 power x, it means 3 power x equals 3 power minus 1. So x equals minus 1. Okay, but for a equals minus 2, that is 3 power x equals minus 2. Convert in logarithm will be 3 log minus 2, or x equals log 3 minus 2. Yeah, that's the solution. Number 4, quadrilateral OABC is shown on the following set of axes. This is the quadrilateral OABC. OABC is a symmetrical about OB. The symmetry. OB is the symmetry. A has coordinate point 6, 0. This. C has coordinate point C 3, 3 square root 3. Write down the coordinates of the midpoint of AC. Right, so the midpoint of AC, I will create the strike line AC. Wait, this, okay. Sorry. This, sorry, the strike line, it will be like this. Oh, okay, like this, the strike line. Okay, and this, the midpoint. So, A is 6, 0, and this is C, 3, 3 square root 3. Okay, so the midpoint, I'm going to write in here, midpoint is consists of X and Y. Okay, so X equals 3 plus 6 over 2. 3 plus 6 over 2, it is 9 half. So 9 half here. And then Y equals 3 square root 3 plus 0, 1 0 over 2. So it is 3 square root 3 half. So this is 3 square root 3 half. Okay. This, the midpoint. Okay. Part 2, hence or otherwise find the equations of the line passing through the points O and B. So we're going to find this strike line equation, strike line OB. Part 2 here. Firstly, I will find the gradient y over x. Okay, y is 3 square root 3 half over 9 half. So becomes 3 square root 3 half times 2 over 9. So gradient is 3 square root 3 over 9 divided. It becomes square root 3 over 3. This is the gradient. And the strike line through through origin 0, 0. So we are going to find through this formula y minus y1 equals n x minus x1. And this, so y minus 0 equals 3 over 3 x minus 0. So let's go to here, y equals square root 3 over 3x. This is the strike line, the equation, the function. This one, the equations of or the strike line function. Given that OA is up perpendicular to AB. OA, OA perpendicular, it means 90 degrees here, perpendicular. Okay. Find the area of the quadrilateral OABC, right? We are going to find this area, how much? B. At B, okay, at B here, this point B, okay. This is it is 6, okay, 6, okay, and we're going to find this, okay. Y how much, and you can find the coordinate point here. How to find Y? Just substitute 6 into this equation. Substitute 6 into this equation. Y is 6 because X equals 6. So it becomes Y equals 6 by 3, 2 square root 3. So it means the coordinate point here is 6 comma 2 square root 3. 1. Next. So it means we can calculate this area of this right angle triangle. After that, times 2. So area triangle OAB. It is half times OA, AB, half times OA is 6, and AB is 2 square root 3. So it is 6 square root 3. So area quadrilateral equals 2 times 6 square root 3. And it is 12 square root 3. This is the solution. 5. Species of bird can nest in 2 seasons, spring and summer. The probability of nesting in spring is K. The probability of nesting in summer is K over 2. This is shown in the following tree diagram. Okay, these three diagrams. Okay, this is the spring probability, and this is for summer. Complete the tree diagram to show the probabilities of not nesting, okay, in each season. Write your answer in terms of K. Okay, so it means we have to start from here. This is the probability is 1 minus K. If this probability, for example, 2/3, it means this is 1 minus 2/3. Okay. If this probability is 4 over 5, this probability is 1 minus 4 over 5. And it means here 1 minus K half. Okay. What else? This is, I have to look the probability. Okay, same with this one. It means 1 minus K over 2. It is known that the probability of not nesting in spring and not nesting in summer is 5 over 9. Show that 9K squared minus 27k plus 8 equals 0. The probability of not nesting in spring and not nesting in summer is 5/9. Not nesting in spring, 1 minus k, not nesting in summer, 1 minus k half, okay? And it means B part 1, 1 minus k times 1 minus k half equals 5/9. And we will multiply 1 minus k half minus k plus k squared half equals 5/9. And multiply by 18 becomes 18 minus 9k minus 18k plus 9k squared, 10. Okay, so 9k squared minus 27k plus 18 minus 10. And it is 9k squared minus 27k plus 10 plus 8, sorry, plus 8 equals 0. Proof. Both k equals 1/3 and k equals 1 equals 8/3. Satisfy 9k squared minus 27k plus 8 equals 0. State why k equals 1/3 is the only valid solution. Okay, as you know that k is a probability. Okay, and it means k, the maximum k is equals 1, or k, maximum 1. Okay, and it means if k equals 8/3, this number is over than 1. This number is 3 times 2 plus 3. Yeah, 2/3. This is greater than 1. So impossible if k equals 8/3 satisfy for this equation, because this equation for probability equation. Okay, its k is probability. So why? So that's why k equals 8/3 is not the valid solution. Number 6, function f is defined by fx 2x plus 3 over 3x plus 2, where x, rational number. The graph y equals fx is shown below. Okay. The rational function graph. Write down the equation of the horizontally asymptote. Right. Horizontally asymptotes we can find through comparing or through compare the leading terms. Okay, to compare the leading terms, so it is y equals 2x plus 6 over 3x plus 6. So comparing between 2x and 3x. So horizontally asymptote is 2x over 3x. So equals 2/3. So we can write in here that the horizontally equation 2/3. This is the horizontally asymptote. Okay. Consider gx equal mx plus 1. Write down the number of solution to fx equals gx for m greater than 0. If m greater than 0, it means m are 1, 2, 3, 4, 5, so on. All positive numbers. So if gx equals mx plus 1, okay, this is a straight line. For example, if m equals 1, because according to this information that m greater than 0, if I taken m equals 1 and it becomes this function becomes gx equals x plus 1. So it means the coordinate point or the intercept point will be minus 1, 0 and 0, 1. And if we sketch on this diagram, minus 1, 0 here, 0, 1 here. Okay, pay attention that it has two solutions. Wait. Okay, between this straight line and this rational function, there are two intercept points. It means has two solutions. Okay, it's fun. So B, it has two solutions. Next, C, part 3, sorry, part 3, not C. Okay, this is rather the number of solutions. This is part 1. Part 2, determine the value of m such that fx equals gx has only one solution for x. If fx equals gx, it means fx 2x plus 6 over 3x plus 6, while gx mx plus 1. Okay. So I would like to write in here that fx plus gx, it means 2x plus 6 over 3x plus 6 equals mx plus 1 and becomes 2x plus 6 equals multiply becomes 3mx squared plus 3x 6mx plus 6. Okay, becomes 3mx squared. 2x move here becomes plus x plus 6mx. 6 cancel, it's equals 0. So becomes 3mx squared plus 6m plus 1 x equals 0. This is the quadratic equation. The quadratic equation has, put it here, the quadratic equation has one solution if discriminant equals 0. Okay, so it means the a equals 3m. Yeah, we are going to find the discriminant. B equals 6m plus 1 and C equals 0. Okay, so discriminant should be equal 0. The discriminant equals 6m plus 1 squared minus 4 times 3m times 0 equals 0 because one solution. So will become 6m plus 1 squared equals 0 or 6m plus 1 equals 0. So 6m plus minus 1 and m equals minus 1 over 6. So if m equals minus 6, this quadratic equation only have one solution. Okay, part 3. Determine the range of values for m where fx equals gx has two solutions for x greater than or equal to 0. If two solutions, it means discriminant should be greater than 0. Part 3. The discriminant should be greater than 0. So 6m plus 1 should be greater than 0. So 6m greater than minus 1, m greater than minus 1 over 6. So the conclusion is m greater than minus 1 over 6, but less than 0. This is the conclusion. Number 7, Alex only swims in the sea if the water temperature is at least 15 degrees Celsius. Alex goes into the sea close to home for the first time each year at the start of May, when the water becomes warm enough. Alex models the water temperature at midday with the function fx equals a sine bx plus c for x interval 0 to 12, where x is the number of months after 1st May and where ABC greater than 0. The graph of y equals fx is shown in the following diagram. This diagram. Question. Show that b equals pi over 6. Okay. On this this diagram, one wave length is 12. Okay. So 0 to 12. That's one wave. So one wave equals 12. And we learned that one wave actually equals 2 pi. And its function that fx equals a plus a sine bx plus c. Right? I'm gonna make sure first. Yeah, this one a sine bx plus c. So this b, it means uh, it means 12b because one wave is 12. 12b equals 2 pi. So b equals 2 pi over 12. B equals pi over 6. So proof that b equals pi over 6. So write down the value of a. Okay. So the function is fx equals a sine bx plus c. So how we determine a based on the height of this wave. So if we create a straight line here, okay, this is the height. This is a from this point to the top of the wave, or from this point to the minimum point here. So there is 1, 2, 3, 4, 5. So a equals 5. This is a. Okay. So a equals 5. Wait. What else? And next is one C. Okay. C, based on this information that the at least temperature 15 degrees Celsius. So the maximum of temperature is 15. So what happened if x equals 0? If x equals 0 on this graph, if x equals 0, if x 0, the temperature is 15 as well. In this functions, if x equals 0, sine 0 equals 0. So that if if the maximum equals 15, and if x equals 0, so it means a sine 0 plus c equals 15. This is 0, so c equals 15. So c is 15. Alex is going on holiday and models the water temperature at midday in the sea at the holiday destination with the function gx equals 3.5 sine pi over 6x plus 11, where x intervals 0 to 12 and x is the number of months after 1st May. Okay. Using this new models gx, part 1, find the midday water temperature on 1st October, 5 months after 1st May. Okay, so it means gx based on this function 3.5 sine pi over 6 x plus 11. After 5 months, it means g5, it becomes 3.5 sine pi over 6 times 5 plus 11, and it is 3.5 sine 5 over 6 pi plus 11. And if you calculate, the result will be, this is sine 5 over 6 pi is half. So 3.5 times half plus 11. Okay. So it is 51 over 4, or uh, in decimal number 12.75. Part 2. Show that the midday water temperature is never warm enough for Alex to swim. Okay, this part 1, C part 1, and next C part 2. So the function gx equals 3.5 sine pi over 6 x plus 11. Uh, Sine maximum, the value of sine maximum, sine pi over 6x maximum is 1. Okay. The maximum value of sine x is 1. So if maximum, the value maximum of sine is 1, it means we can find the G maximum happening when sine equals 1. So it becomes 3.5 plus 11 equals 14.5. It is less than 15. According to the previous information, that the maximum temperature is 15. So uh, so the water, uh, we can state, or we can write the conclusion that the midday, the conclusion, the midday water temperature is never warm enough for Alex to swim. Okay, what else? D. Alex compares the two models and finds that gx equals 0.7 fx plus q. Determine the value of q. Determine the values of q. So gx equals 0.7 fx plus q. G maximum happening 0.7 if fx equals 20. Okay, that's maximum. If fx equals 20, look here, maximum is 20, happening when maximum equals 20. So 0.7 times 20 plus q equals 14.5. Okay, according to our calculation. So it becomes 14 plus q equals 14.5. So q equals 14.5 minus 14. It is 0.5. This is the value of q. Number 8, the derivative of a function f is given by this one, the rational function. Show that x squared plus 2x plus 2 greater than 0 for all values of x. Okay. fx, the derivative of fx equals 2x plus 2 over x squared plus 2x plus 2, the rational function. The denominator of rational function actually it should be not 0. But I will simplify this denominator. X squared plus 2x plus 2 becomes x plus 1 squared plus 1. Regarding this part, this term, x plus 1 squared, if you substitute x with negative number, with positive numbers, or with 0, the result of this term, never negative, never negative number. Okay, never negative. If you substitute with negative 1, it will be 0. So the result always 0 or positive number. This especially for this part. So it means x plus 1 squared plus 1, the result always positive numbers. Okay, because as now I told you that this term, if you substitute with even with negative numbers and 0, the result never negative. The result will be positive or 0. Okay, so the implication, it means x plus 1 squared plus 1, the result always positive number. So therefore, x plus 1 squared plus 1 is always greater than 0. This is our conclusion. Next. Hence, find the values of x for which f is increasing, right? F increasing if the first derivative greater than 0. So it means 2x plus 2 over x squared plus 2x plus 2 greater than 0. So it becomes 2x plus 2 greater than 0. 2x greater than negative 2, x greater than negative 1. So f increasing when x greater than negative 1. That's the value of x. B, part 1, write down the value of x for which the first derivative equals 0. Similar with part 2 of A. So if the first derivative equals 0, it means 2x plus 2 over x squared plus 2x plus 2 equals 0. So 2x plus 2 equals 0 because the denominator times 0 equals 0. So 2x equals minus 2 and x equals minus 2 over 2 equals minus 1. Part 2. Show that the second derivative equals this expression, the rational function, okay? Part 2. The first derivative, 2x plus 2 over x squared plus 2x plus 2. We're going to find the second derivative. It means I'm going to use, if u, let u equals 2x plus 2, illustration. So the derivative of u is 2, and if phi, the denominator x squared, so it means derivative phi 2x plus 2. So the second derivative we could find through v derivative u minus u derivative phi over phi squared will be x squared plus 2x plus 2 times 2 minus 2x plus 2, 2x plus 2 over x squared plus 2x plus 2 squared. After that, multiply 2x squared, this is 2, okay, 2x squared plus 4x plus 4 minus 4x squared plus 4x plus 4x plus 4 over x squared plus 2x plus 2 squared. It becomes 2x squared plus 4x plus 4 minus 4x squared minus 8x minus 4 over x squared plus 2x plus 2 squared. It is minus 2x squared and minus 4x over x squared plus 2x plus 2 squared. This is the second derivative. Next, part 3. Hence, justified that the value of x found in part B, part 1, this x equals minus 1 corresponds to a local minimum point on the graph of f. Okay. We're going to find the local minimum. Part 3 here. Part 3, x, according to B part 1, x equals negative 1. So the second derivative is this x on secondary substitute with -1. It's going to be -2 minus 4 times -1 over -1 squared plus 2 times -1 plus 2 squared -2 plus 4 over 1 squared, and the result is 2. 2 greater than 0. Greater than 0, it means it is the local minimum point. Okay. What else? It is given that f2 equals 3 plus ln 10. Find an expression for fx. Okay. So let's see. The first derivative is 2x plus 2 over x squared plus 2x plus 2. This is the first derivative of f. So it means fx is integral of this function, 2x plus 2 over x squared plus 2x plus 2 dx. So if u equals x squared plus 2x plus 2, du is 2x plus 2 dx. So this is 2x plus 2 dx is this is du. So we can writing like this: integral du over u, and the result is ln u plus c, or ln x squared plus 2x plus 2 plus c. This is fx. And fx, according to the statement that fx equals 3 ln 3 plus ln 10. Okay, according to this statement, f2 equals 3 ln 10. Okay. f2 equals 3 ln 10. And this fx is f2 equals ln 2 squared plus 2 times 2 plus 2 plus c. This is 10 as well. 10 plus c. So f2 equals f2. So it means ln 10 c equals 3 plus ln 10. So it means c equals 3. So fx, it means fx equals, according to this one, fx, the integral ln x squared plus 2x plus 2 plus 3, because c equals 3. So this is fx. Find the equations of the normal to the graph of f at coordinate point 2, 3 plus ln 10. Okay. So that means we are going to find the gradient first. The first derivative function is 2x plus 2 over x squared plus 2x plus 2. And if x equals 2, based on this coordinate point, that x equals 2. Okay, this is the coordinate point. X equals 2, y equals 3 plus ln 10. The coordinate point 2, 3 plus ln 10. This is the coordinate point. Okay, so it's going to be 4, because if this is 2, 2 times 2 it becomes, just now we already calculated, it is 4 plus 2, okay? And if this 2, 2, so it's going to be 10. 6 over 10. So the gradient equals 6 over 10. But we're going to find the normal gradient. Normal gradient times n equals minus 1. So normal gradient equals minus 1 over m, or minus 1 over 6 over 10. And it is minus 10 over 6. Through 2,3 ln 10. So based on this formula, okay, y minus 3 ln 3 plus ln 10. 3 plus ln 10. M is minus 10 over 6. X minus 2. 3 ln 10 minus 5 over 3x, and it becomes plus 10 over 3, because this is 5 over 3. Already simplify. So it becomes y equals minus 5 over 3x plus 10 over 3 plus 3 plus ln 10. So the equation y, or the function y, equals minus 5 over 3x plus 19 over 3, because 10 over 3 plus 3 equals 19 over 3, plus ln 10. This the function for. Okay, students, if you have any question, you can send me your email. You can ask me through my email. Thank you for joining with me in this lesson. Bye. Sorry, I thought this past paper just until number 8, but in fact, it's number 9. Now, let's be solving number 9. Consider the arithmetic sequence APQ, where APQ unequals 0. Show that to P minus Q equals A. Right, so the arithmetic sequence A, P, Q, so on. Okay, so the common difference of this arithmetic sequence is P minus A or Q minus P. Okay, so it means 2 times common difference to D equals Q minus A. So D equals this one, P minus A. So we can writing 2 times P minus A equals Q minus A. So 2P minus 2A equals Q minus A. Then 2P minus Q equals minus A plus 2A. It will be 2P minus Q equals A. So A equals 2P minus Q. Okay, like this equation. Consider the geometric sequence AST where AST and equals 0 so that S squared equals AT. Okay, what am I thinking here? So it's a different color. Okay, so geometric sequence consists of A, S, T, so on, like, according to this information. So it means the ratio equals S over A. Okay, so R squared is oh, R squared is S squared over A squared. Okay, so it means let's say that R squared squared. Wait, we are going to prove this equation. R squared equals T over A. So yeah, yeah, T over A. This one R squared, and then wait, I'm gonna move here. So R squared equals R squared. So S squared over S squared over A squared equals T over A. So S squared equals T over A times A squared, or S squared equals T times A. Okay. Like this one. Okay. The first term of both sequence is A. It is given that Q equals T equals 1. Show that P greater than half. Like C, I'm going to use a different color. Okay. Okay, see, for the arithmetic sequence A, B, 1, and geometric sequence, it means AS1, so on, so on. So from arithmetic sequence, that D equals 1 minus P. Okay. So, and just now, we already got that A equals 2P minus Q. Then A equals 2P minus 1. And from the geometric sequence, that S squared equals AT. Yeah, but we're going to find through arithmetic sequence that, yeah, S squared, I'm going to writing AT, or S squared equals A, because T equals 1. Based on this information and this information, that S squared equals 2P minus 1. Yeah, because S squared equals A and A equals 2P minus 1. So S for square root 2P minus 1. This part 2P minus 1 should be greater than 0. Should be greater than 0. Why? Because if 2P minus 1 value equals 0, it means S equals 0, and that's impossible. So if values of 2P minus 1 is negative, impossible as well, because it will be imaginary numbers. So that's why 2P minus 1 should be greater than 0. If 2P minus 1 greater than 0, so 2P, it means greater than positive 1. And P greater than half this. Write down the first, or consider the case where A equals 9, S greater than 0, Q equals T plus 1. Write down the first form, the first 4 terms of the arithmetic sequence and geometric sequence. Okay, D. A equals 9, then Q equals T equals 1, and S should be greater than 0. And the arithmetic sequence A, P, Q, so on. And then A, it is 2P minus 1. We already discussed about this. A equals 9, it means 9 equals 2P minus 1. So 2P equals 10 and P equals 5. So it means this sequence APQ will be A equals 9, okay, and then P equals the second P equals 5, Q equals 1, and look the common difference minus 4, so it will be minus 3. This is the first 4 terms. Next, how about geometry sequence? For the geometry sequence, the terms is A, S, T, on. So S squared equals A times T, or S squared equals 9 times 1. S squared equals 9. So S equals square root 9 equals 3. Right. If s equals 3, it means this sequence, geometric sequence, will be a equals 9, s equals 3, and then t equals 1. And look, the common ratio is 1 over 3, so it means 1 over 3. So this is the sequence, geometric sequence, and the first four terms of this geometric sequence is 9, 3, 1, and 1 over 3. And next, the arithmetic and geometric sequence are used to form a new arithmetic sequence UN. The first three terms of UN are U first 9 plus ln 9, the second U 5 plus ln 3, and the third U is 1 plus ln 1. Find the common reference of the new sequence in terms of ln 3. Okay. So wait, part 1. First U equals 9 plus ln 9. Second U is 5 plus ln 3. And the third U is 1 plus ln 1. So the common difference, D equals 5 U2 minus U first, 5 plus ln 3 minus 9 minus ln 9 becomes ln 3 minus ln 9 minus 4. Ln 3 minus ln 3 squared minus 4. So ln 3 minus 2 ln 3 minus 4. And it becomes minus ln 3 minus 4. Or, yeah, this is the solution. Or you can write it like this, minus 4 minus ln 3. So part 2, show that sigma I equals 1 to 10 of ui equals minus 90 minus 25 ln 3. Okay, so based on the information that this n equals 10, so we're going to find S10 of this sequence. The formula of S10 is, okay, part 2, okay, so n half times 2a, the sum of uh, n first term. Okay, so if n equals 10, 10 is 5, 8 times 2a, a is 9 plus ln 9. I'm going to show you a, this is a, or u first, then plus n equals 10, so it is 9, d is 1 times minus 4 minus ln 3. So it becomes 5 times 18 to ln 9 minus 36 minus 9 learn 3. It's going to be 90 plus 10 learn 3 squared minus 36 minus 9 learn 3. And then it is wait. So it's gonna be 9 times 4, 39, and then 5. Oh, it should be multiplied by 5 as well inside here. 180 this one. I mean 180 because 5 times minus 36. Okay, and 5 times 9 is 45. This is 45 actually. Okay, I have to fix first. 45. And 90 minus 180 is minus 90. And it becomes 20 ln 3 minus 45 ln 3. And it's going to be minus 90 minus 25 ln 3. This is the solution. Okay, students. Thank you.